So my name is Gerry Fan. I'm a CEO and co-founder at XConn Technologies. And today I'd like to talk about the XConn CXL Switch, and which enable the composable data center infrastructure. And so the XConn CXL Switch silicon want to solve the following problem. And one of the main problem, as we know that as a server CPU, the core count increase over the time. However, the DRAM, the bandwidth and the capacity, and for each core, as a matter of fact, is decreasing. And that become one of the system performance limiting factors. Because of the advance of the silicon process continue shrinking, and that is much easier to adding more cores into the CPU. And however, because of the HDRAM channels, which is require a lot of the pin count. So to increase the pin count for any of the package is getting more and more challenging. And also the cost associated with increasing this pin count become the exponentially increased. So, however, the requirement for the memory is always been has been continued demanding because of those emerging applications such as in-memory database, computing, and any of these very computation intensive of these genomics calculations, which is required the massive amount of memories. And so does the hyperscaler computing also require a lot of memories. And so that has become a big bottleneck, which is limiting the system performance, and because lacking of the capacity of the memory. So, and the CXL switch is imposed to provide a solution to solve this problem. And so the XConn solution is providing this emergent data center memory architecture. So as we can see that on the right side of the emerging memory hierarchy, and we can see that typically you have a CPU on the top, and right attached with CPU is a DRAM. And traditionally, and below that, you could have some emerging memory technologies such as 3D crosspoint, or ReRAM, or PCM, and other emerging memory technologies. And below that, you have these SSDs for either the low latency SSD or regular NAND-based SSD. And the access time for the DRAM, typically, if you look at it from the hardware perspective, is about like 35 to 40 nanoseconds. And the access for the 3D crosspoint typically is 300 to 400 nanoseconds. And of course, for the SSD is much slower. That's typically is at the hundreds of microseconds. So the DRAM obviously has the shortest access time. And then we can see that there's a big gap between the DRAM and 3D crosspoint. and especially the 3D cross point. And as we all know, that is become pretty difficult for customer to adopt. So in that case, we will see a huge gap between DRAM and SSDs. So the CXL DRAM will provide an ideal solution to fit into these two different type of memory, two different type of storage categories. One is for the non-persistent memory, such as DRAM. The other one is for persistent memory, which is SSD. And we, as a CXL switch vendor, we provide the switch which can enable much shorter latency to access the DRAM. And as we know that the latency is one of the key factors for the system overall performance. And CXL technology, which is enables such application based on its very short latency. And in addition to that, the CXL, the DRAM can be, the capacity-wise can be increased profoundly by utilizing the XConn CXL switch, and to increase the capacity from hundreds of gigabytes to 16 or even higher, 32 terabytes, with connection through our switch silicon. And with the short latency, along with the large capacity, so that is going to give a profound boost to the overall system performance. And in the meantime, this solution will keep the TOC under the check, because again, the memory itself is contributing almost like half of the servers, the overall cost. So for the modern, the composable data center infrastructure, and basically our solution is become the cornerstone and a key component, which is enable the memory pooling and disaggregation in the composable data center infrastructure. As you can see that our silicon-based switch chassis is in the middle of the rack, and through our chassis and the compute chassis, which could be the GPU, or could be the high performance, the data center server CPU. And on the other side, all the CXL-based memory card can be plugged into this memory chassis that formed into a composable memory system. And for any of the upgrade, either for compute chassis and the memory chassis, can be very easily accomplished. And the connectivity between them can be using those cable called MCIO, and to connecting those chassis through our switch and to forming the composable data center, this type of memory disaggregation. And so for XConn, our solution, we offer a CXL 2.0 with PCIe Gen 5 switch. And so we are offering the first CXL 2.0 switch. And our switch has a much higher capacity and to support the large number of the servers and memory systems can be connected together. And we offer much lower latency that is enable the memory access. And our system architecture is optimized to reduce the power consumptions and compare with the existing in a similar application, we have much aggressive power consumption rate. And so our first generation of the switch is being taped out in February. And right now, our engineering sample has been validated in our lab. So I like to talk about the CXL 2.0 switch. And basically, the use case model for CXL 2.0 switch can be as simple as a memory expansion. And as we know that the 2.0 support a single layer. And because of our large port count, and we can connecting a large number of the CXL memory card and could expand the memory capacity in a tremendously. And especially for a type 3 memory device. And we can expand to 15 terabytes based on the current CXL memory card from those vendors. And also our chip, and we also enable to be able to working with CXL 1.1 device, 1.1 server CPUs. And for another use case is more is in the memory pooling. And because CXL 2.0 has the fabric manager and is able to supporting the multiple logical device versus a single logical device. So the multiple logical device combining with our CXL 2.0 switch, we are able to support the memory pooling. And for example, on the picture on the right, the host H1, which can access multiple these devices. And they can be assigned to one of the logical device inside each CXL device. And that makes the multiple hosts is able to share the same physical CXL memory device by allocating these hosts to its own logical device. So that make the memory pooling and become feasible, and which is enable this memory disaggregation. And for the fabric manager is going to responsible to provision when and how these logical device get allocated to those hosts. So it's very much is on demand based, and that greatly improve the memory utilization and efficiency, which is the foundation of this memory pooling concept, and to be able to improve the memory efficiency and reduce the costs of for the overall system. And as a matter of fact, for XConn's CXL switch, we are not only dealing with the CXL 2.0, which is connecting to CXL 2.0 hosts, and we also can have our own proprietary scheme to be able to connecting to the CXL 1.1 hosts on the market, and to enable the memory pooling and sharing scheme. And so this is our product roadmap, and right now we are in the engineering sample phase, and we planning to have our production version of the CXL switch to be available the middle of next year, and to line up with the CXL 1.1 CPU production, and also CXL 2.0 servers available during that time, and continue to be the leader of the CXL switch. And we're planning to have our CXL 3.x with a PCIe Gen 6 speed to be available in the middle of the 2025. And for CXL 3.x, that's going to be open a much wider application, especially in the AI computing and in the GFAM, these type of applications, and to enable more versatile utilizations for the GPU and CPU, and also enable them to sharing the memory as well. And today, we are offering those reference chassis to enable our customers to be able to evaluate the CXL switch-based system more quickly. And so our reference chassis is basically can be ordered and to used by the system integrator or by the cloud service provider, and to build their system to evaluate the advantage and the efficiency of their future system much more easily. Lastly, and I'd like to conclude my short introduction to our product. So if you have any questions, and please feel free to send an email to me. My name is Gerry Fan, and my email address is gerry.fan@xcon-tag.com. Well, thank you very much for listening to my introduction.